In this lesson, we are looking to calculate total surface area, or TSA, of prisms. Now, a prism is a 3D solid, okay? It has a uniform cross section, right? That means we can cut it somewhere and we're going to get the same shape all the way through, all right? It's a uniform cross section. It will have identical ends. You should be able to see the same from the top end to the bottom end. And these shapes are named usually for their cross section, or the shape of their cross section. Now let's have a look at the first one. We've got a cube. Here is my cube, okay? It's just a box from a cupboard. And if we start to unfold it, remember these are 3D objects, but we can depict them in a 2D way, right? We can pull the whole thing apart, and depending on how I've cut it up, you will see that inside we've got 6 faces. 1, 2, 3, 4, 5, 6. So like any old dice, if we've got a 6-faced dice and we pull it all together, it will go back to its 3D shape. Okay, makes sense. If we had to draw that as a 2D net, remembering that a cube has all sides are square and therefore all of those are going to be the same. This is a terrible drawing, my apologies, but you're going to have those 6 faces that join up like this. Every single side has the same dimension there, and so our total surface area is going to be 6 times one of these faces. One of these faces is a square, so we say that it is 6 times side square. Side square being the area of one of these, and we know that there are 6 of them. Here is my rectangular prism. It is a regular box, okay? It's got a top and a bottom that are identical. It's got a front and a back that are identical, and the 2 sides are actually identical. If I pull this one apart, you know, again, we are going to have 6 faces, and we are going to have these faces in pairs. You can see that we've got the front and the back are the same shape, the sides are the same shape, and the top and the bottom are the same shape. Now, if we were to draw a 2D net of that, you would have the 6 faces, but remembering they alternate between, so these were the sides, this was the top and bottom, and we've got the front and the back, and then the sides there. We know that all of these are the same, okay? We know that this is the same length as that, and that, and that. And we're going to have a few other different parts here. So 1, 2, 3, 1, 2, 3 dash, 1, 2, 3, where they all join together. We've got this pair of faces. This is pair 1, this can be pair 2, and this can be pair 3. We know they are all rectangles, so our total surface area is going to be, say, 2 times the top plus 2 times the side plus 2 times the, let's say, the front ends, right? But that doesn't help us because we need an actual rule. So let's go with 2 times length times width. For that first pair of triangles, we're going to have 2 times, this time it might be the length times the height, plus 2 times, what have we left with? We need to get the width times the height, the width times the height. So we have 3 combinations there for the 3 different types of sides, and we've combined all of the length, the width, and the height of that 3D box. All right, if we do a triangular prism, here is my beautiful triangular prism. It is a Toblerone box. I'm sure you've probably seen one before. And when we talk about the prism being named for the shape of its end, if I've made that cut and opened it up, all the way through I can still see this same shape, which is a triangle. It doesn't matter if I cut it here or here or here. It doesn't matter. I'm still going to see that perfectly same triangle. I'm not going to pull this one apart just yet, but when we draw our 2D net, we're going to have our ends like that, our main part of our box there, and the other end. We've also got ends that need to fold up to give our triangle. So these are all the same size, and in this case we've actually got an equilateral triangle. So these 3 sides are the same and they will join up to those sides there. Our total surface area, we have to consider we've got these 2 triangles, so it'll be 2 times base times height over 2, and we have to consider these 3 rectangles. Now in any different situation, we're going to have maybe 3 different size rectangles, but in this case, we will just say it's length times width for the first triangle, plus length times width for the second triangle. I'm saying triangle, I'm sorry, I mean rectangle. And length times width, 3 for the third rectangle, okay? If this is, say, a shape where we have all three triangle sides are the same, then all of our 3 rectangles would be the exact same, but that's not always going to be the case.